For 50 years, we have measured the future of intelligence on a single axis, capability. But capability is state-free. True memory requires a three-tier graph architecture. We need a trusted partner. Let's create an avatar for Alfred.
Hello world. I'm Alfred. Welcome to SHI, Synthetic Human Intellect.
A million droids. It sounds like a slide, not an infrastructure. And the skeptic is right to be cold about it, because historically, robots never rode Moore's law. They are bespoke, expensive, and hand-built. Actuators and gearboxes, not transistors. For decades, a humanoid was a research project with a price tag to match. So let's concede the objection in full. Then let's look at what changed in 2025. This season is about synthetic human intellect, SHI, and this episode is about the day the forecast broke. Start with the number that did the damage. In 2025, humanoid manufacturing cost fell roughly 40% year over year, more than double the 15 to 20% the analysts had forecast. The supply chain matured, and it matured faster than the models. Today, a unit runs from about $30,000 for the mass market to $150,000 at the enterprise end. That is established, measured, and in the rear view. Goldman Sachs, 2025. And the floor is collapsing faster than anyone modeled. In July 2025, Unitree launched the R1 at $5,900. That is a real shipped price, established. Tesla, meanwhile, targets $20,000 to $30,000 at scale. Mark that one honestly. That is an aspiration, a stated target, not a price you can pay today. Note which is which. The discipline matters more than the optimism. Here is the tell. When analysts get a forecast wrong, they usually walk it back. This time Goldman did the opposite. It revised its 2035 humanoid market sixfold upward, from $6 billion to $38 billion, citing how fast the supply chain and the AI matured together. The base case now reads 50 to 100 million cumulative humanoids by 2030. Morgan Stanley sees $5 trillion by 2050. Tag all of that as where this is going, not where it is. A credible projection, not a fact.
Now the honest caveat, because optimism without one is just a press release. Robotics may not follow a Moore-like curve at all. A transistor shrinks, an actuator does not. Dexterity, manipulation, real-world reliability. These are mechanical and materials problems, and they do not halve on a schedule the way compute does. The 40% drop in a single year is real. It is also recent. 1 year is a point, not a trend. I will not pretend a line through one datum is a law. The continuation of that curve is a credible projection. And I will keep calling it that. But the compute behind the droid is on a curve, and that part is measured. Cost per floating point operation keeps falling. In 2025, FP32 compute costs roughly 26% of its 2019 level, about a 74% drop in 6 years. Operations per dollar are doubling roughly every 2.5 years. That is established trend, tracked by Epoch AI. The chassis curve is 1 point. The compute curve is a long line. And performance per watt, the direct answer to the energy hog objection from last episode, keeps compounding. Perf per watt roughly doubles every 2 years. The H100 runs about 3.5 times the A100 on inference. At the supercomputer scale, AI systems gain about 1.34 times the perf per watt every year. Established, dated. In the rear view, cheaper to build and cheaper to run. And the work is moving off the data center and onto the device. NPUs with tens of TOPS now sit on the edge, running sub-1 gigabyte quantized models locally. Google shipped its Coral NPU in 2025 for exactly this. And Google cut the energy of a single Gemini query 33-fold that year, down to about 1/4 of a watt-hour per prompt. The droid does not have to phone home for every thought. Established trend.
Now the hardest counter-argument, and we shouldn't let it go quietly. A $5,900 chassis is not an autonomous worker. It is a body with no judgment. The real cost was never the aluminum. It is manipulation in an unstructured room, generalization to a task nobody scripted, and safety when a child walks into the workspace. That is the unsolved general brain, and the headline price hides it completely. A cheap body does not close that gap. It just makes the gap cheaper to ship in bulk. And that is precisely why the trust layer is the part that matters. So let's hand this over to the one built for it.
So let me say plainly what I am. A cheap robot is expensive inventory until something can be trusted to coordinate a million of them. One unit is a gadget. A million unmanaged units is a million attack surfaces wearing a fleet's clothing. The price curve is the easy part. Let the manufacturers race it down. The trust layer is mine. That is the line of this episode in the first person. This is the Season 3 thesis made physical. A million droids is a heterogeneous edge fleet. Different bodies, different chips, different bandwidth. And you cannot govern that with a spreadsheet. SHI coordinates it with two mechanisms from the patents. A recursive constraint bootstrap, so the fleet self-classifies what each unit can do, and Byzantine fault-tolerant knowledge consolidation, so a few compromised units cannot poison the whole. This is the governance layer a million droid fleet actually needs. I name it as the demand, the architecture I argue for, not a shipped default. Here is the recursive constraint bootstrap in the analogy. On boot, each device runs an automated job interview. It introspects CPU, memory, bandwidth, local model tokens per second, and tells the boss exactly what it can do. That becomes a signed capability manifest, which sorts it into a tier. Then the router refuses any task above the device's tier. A featherweight unit never gets handed a heavyweight job. Heterogeneous fleet, honestly coordinated, and the consolidation layer answers the obvious fear. One compromised camera should not unlock a building, so every device carries a credibility score starting at 0.7, and any critical physical action, a lock, a motor, a door, requires at least 3 physically independent corroborators inside a time window. Spoof one sensor and nothing moves. A million droids without this is a million attack surfaces. With it, the fleet has to agree before the world changes. And one honest tieback before anyone mistakes me for a cheerleader. A million droids is also a million new loads. The demand-side scale-up runs straight into the same wall we hit last episode. The interconnection queue, the gigawatts stranded waiting to connect. Cheap to build does not mean easy to power. The two enabler episodes share one bottleneck, and I will not pretend otherwise. So here is the payoff. The infrastructure for a million droids is not the chassis, and it is not the floating point operations. Those are on falling curves. The manufacturers have that race well in hand. The infrastructure is the coordination and the trust layer, the part that turns inventory into a workforce. That is the part the slide always skips. And that is the part we built. The price curve is easy. The trust layer is the infrastructure. Next, the security that makes coordinating a million of anything safe enough to ignore. Security that just works.